Friends, I will be talking about remote sensing, its basics and application in agriculture. What is remote sensing? Remote sensing is the science of deriving information about an object or phenomena through analysis of data acquired by a device that is not in contact with the object or phenomena under investigation. Just look at the picture, you will see that the object and the sensor is linked by electromagnetic energy. This can come from energy like solar radiation or energy emitted by the object, or it can also be man-made energy, which you will see in the next slide. You see there are two ways of acquiring information, acquiring data about an object or phenomena. One is called passive remote sensing. Here the reflected energy or the emitted energy from the object will be recorded by the sensors. In the active remote sensing, the energy is created and it is transmitted to the earth objects, and the reflected energy is captured by the sensors. And the advantage of the active technique is we can use this technique in all weathers and also at all times like day and night. The basic data content is the spectral reflectance pattern. In this picture we see the reflectance pattern of three important earth surface features. One is water, the other one is soil, the third one is vegetation. This graphs indicates the distinction between these different surface features in its reflectance behavior. For example, water reflects very low, that is the total reflectance is about less than 10%, and the range of reflectance is also limited to the visible region. There is no reflectance beyond visible region, that is in the near infrared region there is no reflectance at all. In the case of soil, we see an increase in reflectance from lower wavelength to the higher wavelengths, and you also see some troughs and peaks. The troughs are the absorption locations by carboxyls as well as water that is present in the soil constituents. In the vegetation case, you see lots of ups and downs or the troughs and peaks in the reflectance curve, and in the visible region you see two low reflectance, that is blue and green, which is due to the absorption of these portion of electromagnetic energy by the chlorophyll. In the near infrared region, that is beyond 0.7 micrometer wavelength, the infrared reflectance is very high and it is about 50 to 60% of the energy that is falling on the vegetation. In the middle infrared region, you see a lot of absorptions, that is due to the water content present in the vegetative tissues. So, these definitely indicate that we can use remote sensing data for identifying the earth surface features like water, soil or vegetation. This graph is a typical graph. A variation in the soil condition or the vegetation condition or water body will have a slight variation in the reflectance curve also. And the other way of looking at the remote sensing data is to generate visual products and interpret either using visual techniques or by digital analysis. In the first picture, you see a black and white picture which is generated with the help of the reflectance from a single band data. You can use any bands of reflectance and generate a black and white picture like this and interpret the data accordingly. For example, the black spots that is seen in the black and white picture is water body, and the bright locations are built up features. On the right hand picture, you see that it is like a color picture, and this is made by using three bands of reflected energy, and this particular depiction is called false color composite, and here green band, red band and infrared band reflectance are used. The vegetation appear red in this picture. This is because of high reflectance in the near infrared region by the green vegetation, whereas water body and soil will reflect less amount of near infrared, and you see a different color for other features. And the third way of looking at the remote sensing data is to calculate some indices and interpret the indices to derive useful information. In this particular depiction, we see an index which is called normalized difference vegetation index, that is NDVA, which is a very popular and very useful index that helps to assess the amount of vegetative biomass, that is vegetation present in an area. Here this value uses red and infrared reflectance. The difference between the infrared reflection and the red reflectance is normalized over the sum of these two reflectance, and we get a range of values ranging from -1 to +1. Higher values on the positive side indicates healthy and thick vegetation, whereas lower values indicates poor vegetation or soil or water body. Negative values definitely indicates water body, and this can be used for assessing the amount of biomass present in a given area. The third approach is to study the temporal changes in a given area. In this picture, we see three different depictions of the same area taken during three different years, that is 1982, 1983 and 1990. Here what is depicted here is NDVA value, that means amount of green biomass that is present in this area. The first picture you see lot of red and yellow patches. In the second picture you see little amount of black as well as red and yellow patches, whereas in the third picture you see lot of green patches. This values shows that 1990 was good year in the Madagascar region when compared to 1982 and 83. So this way of capturing data will help us to monitor the temporal changes that is occurring in a given area. This kind of information can be used in many agricultural applications, and different agricultural applications are land use, land cover mapping, crop inventory, crop health monitoring, soil resource inventory, land degradation, watershed management, command area management, monitoring in season agricultural operations, and also precision farming. In this picture, the graph shown here is generated from the data collected using a ground held radiometer. The reflectance values are plotted here. So you see two different crops reflectance in this graph, and cotton is reflecting relatively higher amount of energy when compared to rice crop. So this tells us that two different crops can easily be distinguished from the reflectance value collected using a remote sensing device. In this picture we see the reflectance from a healthy vegetation when compared to a infested crop. Rice crop reflectance is shown here, and different levels of leaf folder attack is recorded, and the highest reflectance comes from healthy vegetation. The moderate damage will give little lesser reflectance when compared to a severely infested rice crop where the reflectance is very low, and this helps us to see whether a crop is in normal condition or it is affected by some leaf damaging pest and diseases. In this flow chart, the method of using remote sensing data for land use land cover mapping is given. We can use digital approaches for classification of the remote sensing data. Normally we use multi-seasonal remote sensing data like data taken during Kharif season, data taken during Rabi season, as well as the third season also can be included like summer season or ZAR. So these remote sensing data can be used to derive the land use land cover information during these different seasons, and you can integrate these interpretations into what is called land use land cover information. The result of such analysis for a particular location in Tamil Nadu, that is Dharmaburi district, is shown here. So multi-season remote sensing data collected using LIS-2 sensor is used for for classifying the land use land cover in this area, and 20 different categories of land use land cover was derived from this remote sensing technique. So, the results of this analysis is tabulated in this depiction. You see the major categories under level 1 are the forest, the next one is agricultural land, the third one is water body and other categories of land use land cover. In the level 2 categories under forest we can also classify deciduous forest, forest blank and degraded forest. Under agriculture crops you can get cropland, within which cropland during kharif season, crop during rabi season as well as double crop, that is cropped during kharif as well as rabi season, and fallow lands as well as plantation crops. In the water body case we can also distinguish rivers and tanks. So, different land use land cover at level 2 is easily possible when we use list 2 data, that is linear imaging cell scanner type 2 data. So, this helps us to get different land use land cover at level 2. Here we are looking at a false color composite which is generated using green, red and infrared band reflectance. So, this can be used for interpreting soil resource information in this area. So, normally we take this reflectance data during summer season where the crop cover will be very less, and this data can be interpreted, and the technique of physiographic soil unit is used to classify the remote sensing data and integrate with the geomorphology and landform and land use land cover information to generate soil information. So, this is a soil map. We get this kind of soil map from the remote sensing data, and up to series level we can classify depending upon the resolution of the remote sensing data. High resolution data are now available. So, we can go for better mapping like large scale mapping like 1:25,000 or so. Then another application of remote sensing data is terrain analysis. For this we use what is called a digital elevation model. This is derived from stereo data, that is remote sensing data collected about the same area but from two different vantage points. That is, we have sensors which can generate data like this, and we can digitally process this data to generate digital elevation model. With this digital elevation model we can do many analysis and extract lot of information. So, we can extract information about the slope and the direction of slope, then also we can calculate the flow direction of rainwater as well as runoff, and watershed delineation can also be done using this data, and also we can monitor the developments that is going on in the watershed program, like increase in crop cover, decrease in soil loss as well as decrease in silt load in the catchment areas. So, this is possible from the digital elevation model, which is again obtained from stereo data of remote sensing sensors. So, we can apply remote sensing data in many aspects of agriculture, and we can derive lot of useful information using the remote sensing data, and satellite remote sensing data is now available in different resolutions, different temporal periodicity. So, we can use for many applications in agriculture. If you have any doubts, you can refer Manage website or the materials provided by the Manage. So, you can easily understand the concept that I am just explaining in this presentation. Thank you.